We've already talked about one-step equations. Basically, we talked about the inverse operation. And if you noticed, all those one-step equations required one operation to complete them. That's why it's called a one-step question. Well, as you can probably guess, two-step equations are going to require two steps to solve them. You still do inverse operations just like you did with your one-step equations. So if you'll see here, I've got the number sentence equation, and then I've got the model. I will solve both of them side by side. So 2x plus 3 is equal to 7. So we know that we need to get the x by itself, and there are two numbers that I need to get rid of, this 3 and then this 2. So which one do I get rid of first? Think about order of operations. Order of operations, we're solving in a specific order to find a final answer. Here, we have our final answer, and we're trying to work backwards to figure out one of our values. When we're working backwards, we go in reverse. So think about order of operations where adding and subtracting is your last thing. Well, now that we're going backwards, it becomes our first thing that we need to do. So I'm going to separate my equation here. I've got two sides to it. I've got a left-hand side and a right-hand side. Inverse operation, adding 3. Now I need to subtract 3. Remember, you have to do it from both sides. Okay, now this becomes a whole new equation. I'm left with 2x because I didn't do anything to that 2 yet. This went away because I got rid of it. 7 minus 3 is 4. Okay, that was my first step. Now I'm left with 2x equals 4. Well, my second step is I've got to divide both sides by 2. Divide by 2, divide by 2. X is equal to 2. Well, now that I've got my final value, I'm going to go back in and plug it into my original equation to make sure I'm correct. 2 times 2 is 4, plus 3 does in fact equal 7. So over here on my model, same thing. First thing I did was subtract 3. I'm going to subtract 3. Anything that is the same on both sides of your model you have to get rid of. So now I'm left with 2x equals 4. Well, we don't want to know the value of 2x. We want to know the value of one of those x's. So since there are 4, each of those get divided equally among the x's. So x is equal to 2. Here's another example. 2x plus 3 equals 5. I'm going to subtract 3. Subtract 3. 2x is equal to 2. Divide by 2. Divide by 2. X is equal to 1. X is equal to 1. So I'm going to plug that back into my original equation. 2 times 1 is 2, plus 3 is 5. Same thing on my model. Get rid of everything that's the same on both sides. 1, 2, 3. 1, 2, 3. I'm left with 2x is equal to 2. Each one of those x's gets 1 for itself. So x is equal to 1. On this one, you'll see it looks a little bit different because not only do I have x's on both sides, and then I have numbers on both sides. Does not change the way you solve this problem. Does not change it. You have to get rid of trying to get the x all by itself, so I got to get rid of the other numbers. Subtract 1, subtract 1. So I'm left with 2x equals x plus 3. But I still have an x on both sides. I have to get rid of the x. You can only have x's on one side of the equation. So get rid of that x, get rid of that x, and I'm left with 1x is equal to 3. Over here on the model, same thing. Get rid of anything that is the same on both sides. Get rid of 1, get rid of 1x, and I'm left with x is equal to 1, 2, 3. You'll notice that I don't have an equal sign over here on this model because it's on a scale. And anytime you have a scale, you know that to keep it balanced, whatever you do to one side, you have to do to the other. Because think of if you had a scale, if you took something off of one side, well, that side suddenly is not as heavy anymore, and this side gets weighed down. So to keep it balanced, whatever you take away from one side, you have to do to the other side. Sometimes they will show an equation on a balance to show you that it is equal. This side is equal to this side. Okay? Couple more examples. 3x plus 2 is equal to x plus 6. Subtract 2, subtract 2. And I'm left with 3x plus 2 minus 2 goes away is equal to, I didn't do anything to this x yet, so I have to rewrite it. 6 minus 2 is positive 4. Now I have an x over here and x's over here. I have to get rid of this x. I don't want x's on both sides. And if you can think of this x as a 1x, okay? 1x. You don't have to write the 1, but it's there. Okay, so if I've got 3x minus 1x, I'm left with 2x's over here is equal to 4. Divide by 2, divide by 2, x is equal to 2. Let's make sure over here I get the same answer. Cross out 2, cross out 2. Keep it balanced. Cross out 1, cross out 1. I'm left with 2x is equal to 4. Each one of those x's gets 2. This x gets 2, and this x gets 2. Okay. Here are some more equations. I can't really model a division equation. So to get rid of it, add 2, add 2. Remember, my equation is broken up to a left-hand side, right-hand side. So x divided by 3 is equal to 4 plus 2 is 6. So multiply by 3, x is equal to 18. I'm going to plug that back in and make sure that I'm correct. 18 divided by 3 is 6. Minus 2 does in fact equal 4. Here we go. X divided by 4 plus 3 is equal to 5. So I'm going to break my equation up into two sides, left-hand side, right-hand side. Subtract 3, subtract 3. X divided by 4 is equal to 2. Multiply by 4, x is equal to 8. Let's plug it back into our equation, make sure that we're correct. 8 divided by 4 is 2, plus 3 is 5. And that is two-step equations.